and our symbol for sum is Greek letter sigma. Sum of the numbers divided by how many numbers there are. So I'm going to get that by adding up all of the boys, because for the girls we did the median and the interquartile range. I'm going to add up all the boys and divide by 12. And you're welcome to try it too and see if you can get the same answer I do. So when I add those up, I get 987, and I'm going to need to divide that by 12. And that gives me 82.25. Always a little disappointed to see the decimal, but I am encouraged to see that it's a nice, convenient decimal. Because now to get the mean absolute deviation, of course, mean, the M stands for mean, means I'm going to add them up and divide by how many there are. Absolute refers to absolute value, which means distance from 0, but in this case it means distance from the mean. So I have to find how far each one of these data points is from the mean, and then add up those differences and divide by 12, because there will be 12 differences. So I'm going to do that now, and I'm going to put their difference right next to them. Now you can use a calculator to help you with this, or you can do probably a lot of mental math, like 78 to 82 is 4.25. I'm not going to leave the video running for all of this, but I am going to find each difference and write it right next to it. And it doesn't matter if you're doing the 78 minus the 82 or the 82 minus the 78. Just keep them all positive. That's what the absolute means, is we're not worried about anything being negative. They're all going to be positive numbers that we're going to add up here. Okay, so I've calculated all the differences, ignoring any kind of negatives. Now I'm going to add all those numbers up and divide by 12. So this is going to be my mean absolute deviation. So my sum is 85, and there are 12 differences, so I divide that by 12. And that comes out to be 7.083 repeated, so approximately 7.1, which means that, we talked about this last time, each standard deviation, so you know, we said it was basically symmetric. So right in the middle, this would be the mean, and then one standard deviation would be adding 7.0, so I'm sorry, what is this, 82.525 right here. And then if we add 7 to that, so basically 89 point, well, if we're going to round it to 1, 35 would be one standard deviation to the right, and then one standard deviation to the left would be subtracting that 7. So that's going to be around 75, more or less. So 68% of the data will fall between 75 and 89. And then of course we could go a second deviation by adding another 7.1 and subtracting another 7.1 and get about 95% in between these two. 95% of the data will fall between those two. But again, it's just talking about how spread out the data are. So I'm going to leave all the other stuff down there. That was a quick explanation of why we did it. But the point of this video is to show you how to do a stem and leaf plot, specifically a back-to-back stem and leaf plot. So we want to compare the boys and the girls, and since we have the boys on the left, we're going to go ahead and put the boys on the left, and you'll see what I mean here in a moment. So a stem and leaf, the stem is going to be, in this case, the tens place. The leaves will be all the ones. So let's put the girls on the stem and leaf plot first, as theirs is going to be the easier one, because that side's going forward. So our lowest score is in the 60s, so we need to have 60s, 70s, 80s, and 90s. So we don't need anything lower than that. So for the girls, And we want to put them in order from least to greatest from the stem out. So there's no 60s, that's over there on the guys. Then for the 70s, I see a 78, 74, and a 78. So I want to put the 4, then the 8, and then the 8. And what each number represents, this represents 74, this represents 78, and this represents 78. Not too difficult. So then the next one in the 80s, we have an 85, an 87, and an 81, and another 81. So let's put those 81s in there first. Did not mean to get rid of my 78s. Those two 81s. Looks like an 83 and two 85s. Well, I'm going to barely be able to squeeze that on there. No other 80s. It looks like we have two 93s, three 93s. And then I count up to make sure that I have all 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm missing one. It's because I'd marked it off and I hadn't done it yet. 87. So really, I'm going to kind of have to shift this whole thing over here and put that back in now. So that 87 squeezes in. Try again. Alright, so now for the boys' side. So we'll do this part in red. 68, of course, and again it's from the least out to the greatest. So maybe I'll even, because I got a lot going on over there. Now as I look through the 70s, I've got a 72, 76, 78. So two 76s and a 78. And then in the 80s, I've got an 81 and an 85, and then two 87s. And then in the 90s, I've got two 91s and a 95. And then we always have to do a key. And that key, I usually like just to take this right here and write that down exactly as you see it. Usually we set it a little off to the side, but this one's going to take a while. So 1/9/3. And then you write that equals 91 and 93. And that way, because this stem right here can be the tenths, which it tens, which it most commonly is, but it could be tenths, it could be ones, it could be thousands, it could be hundreds, and so the key allows us to know that in fact this one is a tens, and then all the leaves are the ones. Now we can describe the distribution of data from here, and before in part 1 we said that the girls' data were skewed according to the dot plot, but if you look at it now, we've got a stack of 3, a stack of 6, and a stack of 3. I mean, this looks very symmetric now, whereas the boys don't look as symmetric. We do have 2 stacks of 4 in the middle, and then a stack of 3, and then a stack of 1. So even though it's not as symmetric, I still would call that symmetric. The peak is still in the middle. Now, one thing to keep in mind that whether we're using the interquartile range like we did in part 1 for the girls, or the mean absolute deviation, the point of this is to talk about how spread out for the interquartile range, the middle 50%, and for the mean absolute deviation, one standard deviation, how spread out that middle 68% is.